From year to year, the moon never seems to change. Craters and other formations appear to be permanent now, but the moon didn't always look like this. Thanks to NASA's Lunar Reconnaissance orbiter, we now have a better look at some of the moon's history. The moon likely started its life as a giant ball of magma formed from the remains of an impact on Earth about 4.5 billion years ago. After the hot material collected into a sphere, the magma began to cool, eventually forming a crust on the surface of the moon with the magma just underneath. Around 4.3 billion years ago, a giant impact battered the moon's south pole, forming the South Pole Aitken Basin and sending debris as far as the opposite side of the moon. This impact marked the beginning of a period that would cause large-scale changes to the moon's surface. One by one, more huge collisions shaped the terrain, some forming large basins that would eventually fill in to become the dark-colored patches of the moon, known as maria. They began as normal craters, but soon started to change due to the size of the impact on the relatively thin crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through the cracks caused by the impacts. The resulting volcanic activity spread lava throughout the craters, gradually filling them in and cooling. Because of the high iron content of the basalt in the rock, the maria reflect less light and therefore appear darker than the surrounding highlands of the moon. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The moon continued to be battered by other impactors, although they were much smaller than the objects that formed the largest basins. Some of the largest, most recent, and best-known impacts from this period include the Tycho, Copernicus, and Aristarchus craters, which are unique due to the complex system of rays that stretch out from the impact site. Finally, we arrive at the moon that we see today. Though the surface continues to be affected by impacts, the rate has slowed down drastically to the point where the moon appears unchanging to the human eye, as a permanent record of its own history, and a glimpse of how craters may have formed here on Earth. To nearly everyone, the moon appears to be a sterile, gray, unchanging world. But while the moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. Using new elevation measurements, we can clearly see the effects of what is likely the last giant impact event in lunar history, with its outer mountain rings rising many kilometers above the lowest points inside the crater. The interiors of some craters in the moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size. One of the youngest large-scale impacts on the moon is the Tycho crater. This fresh crater may have formed only 108 million years ago, when dinosaurs roamed the Earth. We now also have an extreme close-up view of the crater's central peak, revealing a mountain with sharp edges, building-sized rocks, and a central boulder about the size of a baseball stadium. The Aristarchus Plateau is another recent lunar formation that has long interested scientists and astronomers. The crater itself formed in the same era as the Tycho crater, and what appear to be snaking river valleys were actually carved by ancient lava flows. Next, we arrive at Mare Serenitatis on the near side of the moon. In December of 1972, the crew of Apollo 17 landed in the Taurus-Littrow Valley, marking the last time humans have visited the surface of the moon. With images from LRO's narrow-angle camera, we can clearly see the evidence of that visit. In this image, you can easily see the base of the lunar lander, along with the lunar rover, parked far from the blastoff zone. You can also clearly see the astronaut trails and the wheel tracks left on the lunar surface. We now head to the far side of the Moon, which cannot be seen from Earth. Our first stop is the Compton-Belkovich region, which shows evidence for young volcanic activity in the far side highlands. This feature is unique not only because it is isolated from other volcanoes in the area, but also because it is located nowhere near the Maria, where volcanoes are usually found. Also, on the far side we find the Jackson crater, which, like the Tycho crater on the near side, has an extensive and complex ray system. In fact, this crater is often considered to be like a twin to Tycho. Finally, the Tsiolkovsky crater stands out as an excellent example of a far-side crater filled with a sea of ancient lava, known as a mare. It is particularly interesting to scientists and other observers because of its isolation from other similar craters, as well as its beautiful central peak. As we continue to study the Moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the Moon and better understand the history of our solar system.